a quiet archive record. Tonight, we're stepping into a slow unfolding. Settle in, let the outside world dissolve, and gently descend into tonight's world. Imagine a ship that never stops accelerating. Not a sprint to a nearby star, but a long, patient climb into speeds where the universe itself begins to look different. Tonight, we will board a perpetually accelerating spacecraft, and we will travel so far that the familiar night sky becomes a memory. We will move through a documentary-style record of what the crew would actually see, what the instruments would actually say, and what the human body and mind would actually endure. We will make time the main character, because as the ship accelerates, time does not pass the same way for everyone. You will hear moments like these. 50 years have passed on the ship, but 700 years have passed on Earth, and everything you once knew has changed. We will keep the science sound, without drowning in equations, using clear images and grounded facts, so you can feel the scale and still understand it. This is a journey to the end of the universe. Chapter 1. Boarding the ship that refuses to coast. The first thing you notice is the quiet, not silence, not the absence of sound, but the disciplined hush of a machine designed to run for a lifetime. The dock is enormous, a ring of steel and composite, a halo of lights, a place built less like an airport and more like a cathedral for engineering. The ship is called perihelion, a name that means the closest point to a star, which is almost funny, considering this ship is meant to run away from every star. From the outside, perihelion looks wrong. Most spacecraft in movies are needles, or discs, or something sleek. This one is a long, thick spine, with a habitat section shaped like a stretched cylinder, and behind it, a drive section that looks like a black, armored throat. You are not boarding a vehicle. You are boarding a closed world. Before you step through the pressure door, a technician reads out the rules. Not rules like a school, rules like a life support system. Air is recycled, water is recycled, food is grown, waste is processed. Every gram is accounted for. Every system has redundancy, and every redundancy has redundancy. And then the technician says the sentence that changes the feeling of the mission. We will not be coming back. Not because of tragedy, not because of war, because the point is to go so far, and to go so fast, that return is not meaningful. Return would not bring you home. Return would bring you to a different civilization. You sign, you step through, the door closes. Inside, the air smells clean, with the faintest hint of metal. A smell like a new elevator, except this elevator is a planet-sized commitment. A guide meets you. The guide is calm, professional, and speaks the way museum docents speak when they are showing you an exhibit. Except, the exhibit is your life. Welcome aboard. We will begin acceleration in 7 hours. 7 hours. Time has a strange taste on the day you leave. The crew is small, a few dozen people, not 1,000, not a city. This is not a generation ship built for a society. It is a documentary mission, a human witness mission, a moving camera. It's built for one lifetime. Not because the ship cannot last longer. It can. But because the story we are telling tonight is about the ultimate trade, the trade between distance and time. The goal is not to reach a particular planet. The goal is to traverse the observable universe as much as physics allows, within a single lifetime of ship time. The ship will do this by accelerating continuously. not forever. Forever is a big word, but long enough that the crew sees what almost no one will ever see, a perpetually accelerating spaceship. There is a gentle lie inside that phrase. Perpetual does not mean infinite. Perpetual means as long as the fuel and the heat management allow, as long as the structure can take the stress, as long as the humans can take the monotony. The drive is the heart of it. A fusion torch, not the weak kind, not the kind that barely holds the plasma. A mature fusion system, fed by stored pellets, magnetically pinched, and aimed like a bright spear. The ship carries reaction mass, not gasoline, not oxygen tanks, reaction mass. For most rockets, reaction mass is a tragedy. You throw most of your ship out the back, just to move the remaining part forward. For perihelion, reaction mass is the entire concept. A continuous push means continuous exhaust. That exhaust streams into the dark, an invisible comet tail. In the briefing room, a screen shows a simple animation. Acceleration for months, for years. Speed climbs. The presenter uses an analogy. Imagine you are in a car and you press the accelerator gently, just enough to feel pushed into your seat. You do not stop. You do not let up. After 1 minute, you are going fast. After 1 hour, absurd. After 1 day, you are a legend. The difference in space is that there is no speed limit sign. There is only the speed of light, and you will never reach it. But you can get close, and close is enough. The ship is built like a skyscraper lying on its back, so that acceleration can pretend to be gravity. As long as the ship is accelerating at 1 Earth gravity, 1 G, then your feet feel weight, your blood behaves, your bones stay dense, your muscles stay honest. It is a trick, a beautiful trick. The floor is down, only because the ship refuses to stop. The crew quarters are simple, compact rooms, a bed, a wall display, a few personal items allowed, a small window. But the window does not show stars. It shows a camera feed, because real windows are weak points. The guide points out the camera feeds. Forward sky, rear sky, thermal, radiation, dust impacts. You will learn to look at these screens, the way sailors learn to read the horizon. In the common area, there is a table, a few chairs, a plant wall, a small kitchen, a library, and everywhere there are panels, labels, arrows, warnings. This ship is designed for people who do not want surprises. The commander is introduced, a person with a voice that sounds like it has read too many reports. We accelerate for as long as we can. We record everything. We transmit what we can. But at some point, signals will take too long. And then we will become a message in a bottle. A message in a bottle. That is the mission. A documentary with no guarantee of an audience. In the hours before acceleration, the crew does ordinary things. They check seals. They check pressure. They check the fusion feed. They check the radiation monitors. They also do human things. They eat. They talk. They pretend this is normal. The ship has a museum corner, a deliberate choice, a small wall of objects, a printed photograph of Earth, a metal plaque, a few pieces of old technology. The plaque reads, "For those who will not share our time, it is both romantic and brutal." In the final hour, the ship closes the last connection to the dock. A soft mechanical shudder, a sense of a giant hand letting go. And then there is a voice on the speakers. Begin, burn. You feel it, not as violence, as certainty. The ship leans into you. The floor becomes heavier. Your stomach shifts. 1 G, a familiar weight. unfamiliar pull. The crew smiles because the ship feels like home. Outside, Earth is a bright coin, a blue-white marble. You watch it on the screen. It slowly shrinks. In the first minutes, it is still close enough that you can pretend you are leaving a place. But the ship is not leaving a place. It is leaving a time. The first day passes. The ship accelerates. The crew sleeps. The ship accelerates. The crew wakes. In the first week, you still think in terms of distance. How far are we? How fast are we? The instruments answer. Velocity relative to Earth. A fraction of a percent of light speed. Nothing dramatic. But the fact that it is sustained, that it is constant, that is the dramatic part. A second screen shows something else. Proper acceleration. The number does not change. That is the point. And then, in the first month, something subtle happens. The stars ahead begin to concentrate. Not because they move, but because your perspective is changing. Aberration. A real effect. At high speeds, light appears to come more from the direction you are moving. The universe begins to bunch up in front of you, like rain hitting a windshield. It is the first hint that the sky itself will not stay the same. A flight engineer walks you through it. At rest, we are surrounded. At speed, our forward direction becomes more important. The engineer points to a cone. At very high speed, most visible light will seem to come from within a narrow angle ahead. Behind us, space will look emptier than it really is. And then the engineer adds a detail that makes it feel real. Astronomers call this the headlight effect. Like driving at night, you are not shining the light, you are collecting it. The engineer smiles, and the universe does not care that it looks cinematic. In the first time dilation briefing, a crew member stands in front of a screen. On the screen is a simple diagram, no equations, just two clocks, one labeled ship, one labeled Earth. At low speed, the clocks agree. At high speed, they do not. As your velocity increases, ship time slows relative to Earth time, not because of magic, because of how space-time works. The presenter says it gently. If we keep accelerating at about 1 g, within about 1 year of ship time, we will be moving so fast that years will be passing on Earth faster than they pass for us. The presenter pauses. This is not a metaphor. A technician in the back asks, "So are we stealing time?" The presenter answers, "No, we are choosing where we spend it." The crew listens, because this is the point. This ship is a machine for trading time. You trade your outside world for a path through the cosmos. The first year is a blur of routine, maintenance, training, recording, meals, sleep. The ship becomes a workplace. And then, near the end of the first year, there is a message from Earth. It is not dramatic. It is a normal upload. News, cultural updates, a few personal notes. But attached to it is a timeline. It estimates the dilation factor. Ship time, 1 year. Earth time, 1.2 years. Not much, yet. But the curve is steep. And that is when the documentary voice inside you changes. Because you realize this is not just a journey through space. It is a journey through history. The documentary record captures the first real measurements. A navigation officer reads a checklist into the camera. Acceleration stable, crew health stable, fusion feed stable, waste loop stable, radiation nominal. Then the officer adds the kind of detail that makes it feel human. And yes, we still argue about what day it is, because on a ship, day is no longer the sun. Day is lights. The habitat lighting system is programmed to mimic sunrise and sunset. At 06:30, the ceiling panels shift from deep amber to pale white. At 21, they slide back into warm orange. The crew chose this on purpose. Circadian rhythms are not optional. If you break them, mental health follows. The ship has no windows, but it has weather. A soundscape generator plays subtle air movement. A small humidifier system changes the feel of the air. A plant wall releases scent in tiny cycles, not as decoration, as medicine. The ship also has a time lab, a place where time is treated like a measurable substance. 2 atomic clocks sit in separate compartments. One is used as the ship's reference. The other is used as a witness. They are compared constantly. If they drift, engineering is called. Because the entire mission, at its core, is about the honesty of the clock. A mission's scientist explains this to the camera. In popular stories, time dilation is a punchline. Here, it is the plot, so we measure it. We do not trust our feelings. We trust oscillations. The scientist holds up a small device, a radiation badge. They add, and we trust our shield, because time dilation does not protect you from particles. The ship uses multiple layers of protection. It maps the density of gas ahead. It adjusts its angle slightly, not enough to change the destination, but enough to avoid thick clouds. It schedules maintenance windows when the forward impact rate is lowest. The crew learns the difference between romance and reality. A perpetually accelerating ship is not a smooth ride. It is a living system, constantly balancing thrust, heat, fuel, shielding. The crew also learns something else. Speed is not just speed. Speed is how your ship interacts with the universe. At first, a star is a dot. Then, with better instruments, a star becomes a disk. Then, with more speed, a star becomes a shifted spectrum. The ship's instruments show the crew how their motion changes the sky. A technician pulls up a graph. The same star, seen forward and seen sideways. Forward, blue shifted. Side, less shifted. Rear, red shifted. The technician says, "You are watching Relativity, not in a book, in your eyes." In year 1, the ship sends its first major public broadcast. It is a calm compilation, a tour, a few interviews, a few shots of Earth shrinking, and then a simple message. We are accelerating. We are healthy. We are recording. The ship transmits it. Earth receives it, and Earth responds. The response is a chorus, millions of messages. Most are filtered, some are chosen. A few are played for the crew. The crew listens. Some laugh, some go quiet, because already they can feel the distance growing, and they know this is the last time it will feel like a conversation. In the last hours of the first year, the crew records a final tour of the ship for the archive. They walk the corridor slowly, letting the camera linger on details. A hatch labelled Water Loop B, a panel labelled CO2 Scrubber, a red handle labelled Fire, a yellow placard that says, "Do not improvise." The camera follows their hands as they open a service bay. Inside, a tangle of pipes, condensers, filters, a quiet system that turns breath into air again. A crew member explains it simply. On Earth, you do not think about air. Here, air is a machine. They move to the communications room, a dish inside the hull, a laser comm unit, a clock synchronized to Earth, with a note under it. Enjoy this while it lasts. Then they move to the drive monitoring station. No windows, only graphs, plasma temperature, magnetic confinement, pellet feed rate, a nozzle throat temperature. An engineer says, "The drive is not a rocket. It is a furnace with opinions. It wants stability, we give it stability. The camera follows them into the quiet corner of the habitat, where a small shelf holds personal items, a photo, a coin, a handwritten note. The crew member reads it. If you are watching this, remember that we did not leave because we hated Earth. We left because we loved it, and we wanted to understand what the universe would do if we tried to outrun it. They put the note back, they look into the camera, and then they say something that feels like a documentary chapter title. From here on, time will be our ocean, and we will be sailing. Chapter 2. The first 50 years and the first 700 time dilation is the kind of idea that feels like a puzzle until you live inside it. In the second year, the ship is faster. The stars are stranger. The forward direction is brighter. The rear direction is dimmer. The crew begins to see the cosmic microwave background, the faint afterglow of the Big Bang. Shift. At rest, it is microwaves. Invisible, a cold bath of ancient light. At high speed, it blue shifts in the direction you are moving. It climbs into infrared, then visible, then ultraviolet. You are not just moving through the universe. You are changing the energy of the universe that hits you. The ship is shielded. A thick forward shield, layers of material, water tanks, hydrogen-rich plastics, magnetic fields, all meant to absorb and deflect. Because at these speeds, a grain of dust is not dust. It is a bullet. The documentary record lingers on the shield. It is not heroic. It is practical. It is thick, not for impact, but for radiation. And it has a quiet elegance. The forwardmost layer is sacrificial, a sheet of material designed to be replaced. Behind it, water. Water is life. And water is also excellent radiation shielding. Behind that, polyethylene, hydrogen-rich, good at slowing energetic particles. And behind that, a magnetic field coil. Not to stop all radiation. Magnetic fields cannot block photons, but to deflect charged particles. The engineer narrating the tour says something you will remember. At these speeds, we are not afraid of the dark. We are afraid of the invisible. The crew runs impact drills. They practice sealing compartments. They practice replacing panels. They practice treating radiation exposure. In the 10th year, ship time. Earth is still talking. The messages arrive delayed, but not insane. The crew receives video, a politician giving a speech, a pop song, a sports highlight. The commander watches, smiles. It is comforting, because it makes Earth feel like it is still there. But the timeline chart changes. Ship time, 10 years. Earth time, 20 years. Still not monstrous, but unmistakable. The documentary record pauses to explain the idea, without equations. If you sit still, and I move very fast, we will not agree on how long things take. You will say that my clock runs slow. I will say that your distances are shorter. Both can be true, because space and time are connected. On the ship, this stops being a thought experiment and starts being a calendar. The crew begins to understand a painful truth. Even if your friends on Earth live long lives, you will not share time with them. You will not grow old together. Your messages will become a conversation with ghosts. In year 15, ship time, a crew member receives a message from their mother. It is a simple video, a face, older, smiling. The mother says, "I watched your launch again." They replay it every year. The crew member laughs. Then, quietly, they cry, because to them, launch was 15 years ago. To their mother, it is now a cultural holiday, a piece of history. By year 20, Ship time. The crew receives another message, a private message, a voice you recognize. But the voice is older. Your friend is now a middle-aged person. They talk about their children. They talk about the world. They talk about the ocean being calmer, and the politics being weirder, and the technology being more intimate. They say they are proud. They say they miss you. And then they say something that hits like a soft punch. I know you are only 20 years older, but for me, you left decades ago. And you realize this is what dilation does. It does not just change clocks. It changes relationships. It changes grief. It changes what it means to be present. The documentary voice returns. On a ship that keeps accelerating, the crew can experience decades, while Earth experiences centuries. How? Because as the ship approaches light speed, the difference between frames grows. At 1 g of constant acceleration, a ship can reach a speed extremely close to light speed in a surprisingly short proper time. Not because the ship is cheating, because constant acceleration adds up. And when you are near light speed, a little more speed makes a huge change in time dilation. The ship's navigation computer displays 2 timelines: ship clock, external clock. The curve between them steepens. The mission scientists keep the crew grounded. We are not breaking physics. We are using it. They add, and we are paying the price. The price is energy. The price is shielding. The price is that the outside universe becomes hostile. In year 30, ship time. Earth sends a package. It arrives. The delay is longer now, but what is inside feels like a museum exhibit. Languages shift. Slang becomes unfamiliar. Fashion becomes alien. You watch a news clip. The anchors speak with accents that did not exist when you left. And then there is the first truly shocking timestamp. Ship time, 30 years. Earth time, 200 years. 2 centuries. The room is quiet. 200 years. Entire nations have risen and fallen. Entire technologies have become obsolete. Entire philosophies have cycled. You are a person from the past, but you are also still alive, still inside a working body. The ship becomes a time capsule. By year 40, ship time. Earth time is no longer a neat number. It is now a story told in footnotes. The crew learns about things that happened after they left. A breakthrough in energy, a breakthrough in medicine, a collapse, a rebuild. Some of it feels hopeful, some feels distant. And then there is a message with a strange tone. It is from a historian, not a friend, not a family member, a historian. They say, if you are receiving this, know that you are now part of our collective memory. We teach your mission in schools. You look around the common area. You are not a crew. You are a chapter in someone else's textbook. By year 50, ship time. The ship has been accelerating for half a century. The crew has grey hair. Some have died. Some have retired into quiet roles. New crew have not been born. Again, this is not a population ship. This is a finite cast. And then the commander calls a meeting. The data is in. Ship time, 50 years. Earth time, 700 years. 700. The room goes quiet. 700 years. Everything you once knew has changed. Every city you remember may have been rebuilt. Every friend you loved has been gone for centuries. And yet, Earth is not a ruin. The messages show a world that has adapted. Maybe it is better. Maybe it is worse. It is different. The last video from Earth is simple. A view of an ocean, a view of a city, a view of a forest. The video ends with a sentence. We are still here. The crew watches it twice. Then, the connection begins to fail. Not because Earth stops transmitting, because the ship is too far. The signal takes too long. The ship cannot wait centuries for a reply. The commander says it plainly. Soon, our last real-time connection ends. After that, we transmit, and we do not expect to hear back. You are now a moving historical artifact. The documentary record becomes more intense, because the audience, if there is an audience, will be an audience from the far future. You begin to narrate with that in mind. We are leaving the era where Earth can reach us. We are entering the era where we are alone. The ship continues to accelerate. The universe continues to change shape. There is a period in the middle of the mission where time dilation stops being a number and becomes a lifestyle. The ship adopts a new calendar: ship year, Earth year estimate, signal delay estimate. The board in the common area is updated weekly. A crew member writes in neat block letters: ship age, 41 years. Earth age, approximately 320 years. Estimated message delay, too long to matter. A younger technician laughs and says, "We are older than our own governments now." The commander replies, "We are older than the idea that launched us." The documentary record adds context. On Earth, projects are funded by politics. Politics are funded by attention. Attention is funded by novelty. Perihelion is the opposite of novelty. Perihelion is endurance. So the crew becomes their own audience. They do not perform for Earth anymore. They perform for the archive, for the idea that someone, someday, will watch this. In year 45, ship time, there is a medical event, a small stroke. A crew member survives, but their speech changes. They struggle to find words. The ship doctor records the incident, not as gossip, as data. Because if you are going to travel to the edge, you must document what the edge does to humans. The doctor explains. Radiation exposure accumulates. Even with shielding, even with careful routing, even with luck, the crew becomes more cautious. They reduce time near the forward shield. They increase shielding behind workstations. They accept that the ship is not an invulnerable bubble. It is a compromise between mass and protection, and the universe is patient. In year 50, ship time, when they read the 700 years figure, it lands with extra weight. Not only because everyone they loved is gone, but because the ship itself has become the only home they have. There is no Earth memory that can compete with 50 years of corridors. The ship is now their planet, their street, their sky. And that is when the commander says something that feels like an oath. We keep recording, we keep pushing, we keep the light. Between the 50th year meeting and the next phase, there is a quiet season, a season where the crew stops waiting for Earth. They stop checking for messages, they stop imagining replies, and they begin to live as if the ship is the only civilization that exists. The documentary record captures this shift. A crew member says, "When Earth was talking, we were guests. Now, we are natives." They mean it emotionally, but it also becomes operational. Schedules change, reporting formats change. The archive becomes the primary output. The mission team creates a standardized log, read aloud once per day. Date, ship time, acceleration, estimated gamma, radiation, shield temperature, fuel remaining, crew health summary. It is repetitive. It is also calming, because repetition in deep space is structure. A young engineer jokes, "We are the smallest country in history." The commander replies, "Then act like it." They begin to codify small laws, noise rules, sleep rules, work rotation rules, conflict resolution rules, not because they expect chaos, Because humans create chaos when bored. The psychologist explains it. When your environment is constant, your mind looks for change. Sometimes it finds it in conflict, so we give it change in safer ways. The documentary shows one of those safer ways. A classroom. Yes, a classroom. Even for adults. A mission scientist teaches relativity, not with equations, with scenes. They talk about a light clock, a beam bouncing between mirrors. They say, if you move, the light travels a longer path, so the clock ticks slower. This is why our ship time is different. A crew member asks, so is the universe cheating? The scientist answers, no, the universe is consistent. We are the ones moving. That lesson becomes a mantra, consistent, measured, recorded. Then, one day, the forward sky feed changes in a way the crew can see without instruments. The stars ahead are not just bunched, they are brighter, not a little. Enough to notice. The commander calls it out. We are entering the regime where the sky will become loud. The crew watches. The documentary voice becomes quiet, because now the universe will begin to look like motion. Chapter 3. The sky turns into a cone of fire. At slow speeds, space is dark, a sprinkle of stars, a gentle glow. At near light speeds, space is not dark, it becomes bright. Not because stars are closer, because their light is being shoved, relativistic beaming. The universe in front of you is squeezed into a narrower angle. More photons arrive from forward, fewer from behind. And those photons are bluer. A star that was red becomes white. A star that was white becomes blue. A star that was blue becomes ultraviolet. The crew watches the forward camera feed. The star field is no longer a calm background. It is a funnel, a bright cone. The ship's shield heats. Not from friction. Space has no air. From radiation. From impacts. From the energy of light itself. The ship must dump heat. Radiators glow, not visible to the eye, infrared, but the sensors show it. The ship is a moving furnace. The documentary record slows down and becomes technical, but not complicated. A scientist speaks into the camera at high speed. Your view of the universe is distorted, not by a lens, by motion. They show a simple graphic. Light that was coming from the side now appears to come from forward. Light that was low energy becomes higher energy. They pause. This is why our forward shield is not optional. The crew demonstrates a small piece of dust, a micrometeor. At Earth speeds, it would be harmless. At near light speed, it becomes catastrophic. The scientist adds another detail. Even a single hydrogen atom can carry enough energy to damage materials. The ship's nose is constantly being sandblasted by the thin gas between stars. On the hull cameras, you see tiny flashes, not explosions, impacts. The system logs them, impacts per hour, impacts per day. The crew replaces the sacrificial layer. They do it with robotic arms. No one goes outside. Because outside, there is no outside. There is the forward radiation. The documentary voice becomes quiet. This is the part people do not imagine. They imagine speed as a number, but speed changes what the universe does to you. At these velocities, the cosmic microwave background in front is no longer microwaves. It becomes a flood of higher energy photons. It becomes a kind of headwind of radiation. The ship's shield is thick for a reason. In the labs, the crew runs models. If we accelerate too long, the blue shifted background becomes dangerous. It will become X-rays, then gamma rays. You cannot outrun the universe without the universe pushing back. So the ship does something subtle. It begins to reduce acceleration, not to zero, but slightly, Instead of 1G, 0.8, then 0.6. The crew feels lighter, still gravity, but less. This is not a choice of comfort. It is a choice of survival. The ship has a fuel budget, a heat budget, a radiation budget, and the mission is still long. A medical officer explains another reality. If we lost gravity, our bodies would weaken, so we keep some acceleration. But we accept that it must change. The ship is a compromise. The crew begins to measure time in new ways, not in days, in Doppler factors, in how blue the forward sky is, in how thin the rear sky becomes. The rear camera feed becomes a kind of blackness. Stars behind are redshifted, their light stretched, their photons less energetic. The rear sky looks like a desert. The forward sky looks like a bright tunnel. The crew starts calling it the cone. In year 60, ship time, the crew is older. The routines are set. The recordings are abundant. They record the changing sky. They record the strange behavior of light. They record the way distant galaxies distort. Because as you move, you are not only seeing where things are, you are seeing where they were. Light takes time. A galaxy 1 billion light years away shows you a 1 billion-year-old image. At near light speeds, you can cross those distances, but the images you see are still old. This creates a strange feeling. You are racing through space, but you are looking at the past. A crew member says, "We are sprinting through history with our eyes closed." They mean it as a joke. It lands as truth. The crew watches the forward cone. They notice patterns. Galaxies ahead appear brighter, not because they are closer, because their light is being concentrated. The universe becomes a lantern, but it also becomes dangerous. A single atom of hydrogen, at these speeds, has enormous kinetic energy relative to the ship. The forward shield takes hits, tiny, constant, a rain of invisible bullets. The ship's sensors count impacts. And then there is another effect. The ship's instruments begin to see that the interstellar medium is not uniform. It is clumpy. There are regions with more gas. There are regions with less. The ship's navigation becomes a dance. It cannot simply point straight. It must avoid denser clouds. It must plot through voids. It must use maps of hydrogen. It must treat the cosmos like weather. In the documentary Narration, you explain this to the audience. We are not just travelers. We are sailors, and our ocean is made of atoms. In year 70, ship time, communication is gone. Earth is a memory. But the crew still marks Earth days, out of ritual. They celebrate an anniversary. They play an old song. They drink recycled water. They laugh. And then they look at the timeline. Ship time, 70 years. Earth time, thousands. It is no longer precise, because Earth is no longer in contact. The ship is now its own reference. The documentary record becomes the only thread. The crew begins to notice that the ship is no longer moving through a familiar galaxy. The Milky Way, once a band in the sky, is now behind them, not as a view, as a coordinate, a number. The navigation system estimates their position relative to the galactic center. The number grows and grows and then becomes meaningless. Because when you are moving near light speed, inside a ship, your relationship to the map changes. A navigator explains it. We still use maps, but we use them differently. We do not plot in miles. We plot in time. How long until a region of higher hydrogen density? How long until the next safe maintenance window? How long until the next major change in the forward spectrum? The ship becomes a clock moving through structure. The crew also begins to see that empty space is not empty. Sensors detect neutrinos, cosmic rays, background radiation. Even in a void, the universe has a signature, and at high speed, that signature is amplified. The crew learns to recognize the shift. When the forward background moves from infrared to visible, they know they are in deep speed. When it creeps toward ultraviolet, they know the headwind is rising. The ship adapts. It changes acceleration. It changes orientation. It changes the rhythm of the mission. And the documentary record makes a point. This is not a simple line. It is a negotiated path between the crew and the universe. Chapter 4, Crossing the Great Structures. To travel to the end of the universe, you must first understand what the universe looks like. It is not a smooth fog of galaxies. It is a web, filaments, clusters, voids. On the ship, this web becomes a sequence of scenes. A cluster appears, a thickening of galaxies. The forward cone brightens. The sensors spike. The crew watches. In their frame, the distance is contracted. The cluster is closer than it would be for a slow traveler, but the light is still ancient. You watch galaxies that are already old in the sky. You are moving into the past and the future at the same time. The documentary record uses a simple metaphor. Imagine standing in a stadium and hearing a chant. You cannot hear the chant from the far seats instantly. Sound takes time. Light is like that. When we look out, we are not seeing now. We are seeing then. But because we are moving fast, we are sampling many thens within one life. The ship crosses a void, a region of space where galaxies are rare. The forward cone dims. The ship feels lonely. It is here, in the emptiness, that the psychological weight becomes heavy. Because there is nothing outside, no planets, no stars nearby, no hope of rescue, only the ship. The crew develops rituals, a weekly documentary recording, a monthly music night, a yearly remembrance, because humans need time markers, even when time itself is strange. A psychologist records a session for the archive. They speak about monotony, about the way the mind looks for novelty, about the way the universe outside offers novelty, but only through a screen. They say, we are in a moving room, watching the biggest movie ever made, and we still get cabin fever. In the medical bay, the doctor checks bone density, checks blood, checks mental health. The crew is aging, but they are aging slower than the universe around them. The ship's clocks say 90 years. Outside, if you could see it, entire epochs are passing. The crew discusses this. We will approach the edge of what is observable, but the universe will not be the same universe. Because while we travel, the universe expands. Expansion is not like an explosion. It is not matter rushing outward. It is space itself stretching. And that stretching means there is a horizon, a distance beyond which light can never reach us, because the space between is expanding too fast. The end of the universe, in this story, is not a wall. It is a limit of causality. The crew wants the end to be a dramatic thing, a boundary, a curtain. But physics is quieter. Physics is a fade. As the ship moves, more and more galaxies redshift away. They stretch, they dim. Even as you move fast, the universe is pulling things away. A mission scientist explains it in plain terms. There is a distance where, no matter how long you wait, a signal from beyond will never arrive. Not because it is blocked, because space itself is growing. So the crew makes a goal. They will approach the horizon. They will record the fade. They will document what it looks like when the universe becomes an island. The ship approaches the cosmic web's largest features, superclusters, not as names, as shapes. The forward cone shows a thick belt of galaxies. The crew records it. They describe it. Then it passes. The ship has crossed a structure that took billions of years to form in a human lifetime. That is the beauty and the horror. The crew begins to understand that they are witnessing cosmology, not as a textbook, but as weather. They see star formation rates change. They see galaxies collide. They see quasars flare, not because those events are happening around them instantly, because they are sampling different slices of the universe's history. They are moving fast enough that light from different epochs reaches them in a compressed way. The ship's cameras catch a distant quasar, a bright point. The ship's sensors measure its spectrum. The crew uses it as a lighthouse, a calibration. And slowly, that quasar dims, not because it turns off, because its light is redshifted beyond useful ranges. The universe is becoming darker. In the archive, a voiceover notes, "We expected the universe to be full, but the further you go, the more you realize the universe is mostly time." And then there is a conversation in the common area. A young crew member asks, "What will we see at the end?" The commander answers, "We will see the universe run out of light." After the meeting, several crew members stay behind. They talk quietly, not about distance, about meaning. A younger crew member says, "If Earth is 700 years older, then what are we? A historian, a myth, a footnote?" An engineer replies, "We are a measurement. We are a proof that time can be bent." A psychologist adds, "And we are human, no matter how far we go." The documentary record takes a detour here into something the audience can feel. Imagine your phone, your music, your favorite videos. Imagine all of it becoming ancient. Not because you stopped caring, because the world moved on. That is what Dilation does. It turns your culture into archaeology while you are still alive. The crew keeps a small archive of Earth media, a few movies, a few songs, a few news clips. They play them sometimes, not for nostalgia, for grounding. Because on a ship, your mind can drift. It can forget that the outside universe is real. So they watch old Earth footage, waves, rain, people walking on sidewalks. They watch it like a nature documentary, something distant, something impossible. And then, when they return to the forward sky feed, the cone of light feels even more alien, because now, the only weather is photons. The only horizon is redshift. Before they move on, the documentary record returns to something simple, a single human question. How do you know you are really going fast? Because you cannot feel velocity. You can only feel acceleration. So the ship builds its own proof. A scientist leads a demonstration. They choose a pulsar, a rapidly spinning neutron star, a natural cosmic lighthouse. Pulsars emit radio pulses with incredible regularity. The ship points an antenna forward. It records the pulses. Then it points the antenna sideways. It records again. Then it points it backward. The pulses change. Forward, compressed, more frequent. Backward, stretched, less frequent. The scientist says, "This is Doppler. This is motion. This is our speed written into a signal." And then the scientist adds, "Now look at what happens when we combine Doppler and time dilation. To an outside observer, our clock is slower. But to us, our instruments still tick normally. So the universe becomes a set of signals we have to interpret carefully. The ship keeps a wall of plots, spectra, pulse timing, radiation counts, hydrogen density, a living dashboard of relativity. The crew walks past it every day, like you might walk past a weather report. Today, forward sky blue shift factor increased. Today, radiation headwind increased. Today, acceleration reduced by 2%. Today, we crossed a filament. The documentary narration makes another point. Most of the universe is empty, but the empty has structure. A filament is not a wall. It is a gentle increase in galaxies, a subtle thickening. But at these speeds, that thickening becomes a scene. The forward cone fills with faint smears, not stars, galaxies, hundreds, thousands. A crew member describes it. It looks like someone spilled salt into the dark. The ship passes through. The instruments measure gravitational lensing. They watch background galaxies distort, not because the ship is bending light, but because mass between them and the background bends it. The crew sees arcs. They see doubled images. They see Einstein rings, real, not CGI. A mission's scientist speaks softly. When you travel this fast, you do not just change your position, you change which universe you have time to observe. Some galaxies you pass will be long dead by the time your light reaches anyone. Some will still be forming. You are sampling. You are slicing. You are turning cosmology into a walkthrough. And then something happens that makes the crew laugh. The ship's forward camera catches a familiar shape, a spiral galaxy, bright, elegant. The crew stares. For a moment, it looks like the Milky Way. Of course it is not. The Milky Way is far behind, and also far in time. But the resemblance is enough. A crew member says, "The universe is repeating itself." Another replies, "Or our brains are." The documentary voice notes, "Humans are pattern machines. We look for home, even when home is gone." The crew keeps pushing. They cross more voids. They cross more filaments. They record the way the sky ahead becomes narrower. The cone tightens. At extreme speed, nearly everything visible is ahead. The universe becomes a tunnel, and the tunnel becomes a kind of pressure, not physical, psychological. Because when everything is in front, it feels like there is no past, only forward, only motion, only the next measurement. And then, the crew sees a change in the background itself. Not a galaxy, not a quasar, a diffuse wash, the ancient afterglow, the universe's baby picture. And the crew realizes they are approaching the point where the sky is no longer dominated by stars, but by the oldest light. That is when the commander says, "We are leaving the era of galaxies. We are entering the era of background." Chapter 5. The universe. Thins, redshifts, and fades. In the early universe, there were more galaxies visible, more light. In the far future, there is less, because of expansion, because of star death, because of entropy. On the ship, you watch the sky change. The forward cone is still bright, but the sources of that brightness are fewer. The ship's sensors search. They detect faint smudges. They detect distant light. But each year, ship time, there are fewer targets. The crew records this. We are moving into a time when the universe is older. Stars have burned their fuel. A scientist narrates, "Stars are not forever. They are engines. They burn hydrogen. They make heavier elements. They die." In a young universe, there are many bright blue stars. In an old universe, there are more dim red dwarfs, more white dwarfs, more remnants. You can feel it when you watch the forward sky. The colors shift. The brightest objects become rarer. The ship's life support hums. The crew's faces wrinkle. The ship is still accelerating, but not as hard, because the radiation headwind is worse now. The cosmic microwave background is higher energy in front. The ship cannot sustain full acceleration, so the ship chooses a profile. It accelerates, then coasts, then accelerates, in pulses. The crew feels the difference. Gravity changes. Sometimes they float slightly. Sometimes they feel heavy. It reminds them that the trick is not permanent. The ship is not a planet. It is a compromise. The documentary record becomes more philosophical. What does it mean to travel to the end, when the end is a fade? The crew runs the numbers. In their remaining decades, ship time, they can approach the edge of the observable universe in their frame. They can approach the horizon, but they cannot cross it, because crossing it would require exceeding light speed, and physics does not allow that. So the end becomes a limit, a boundary of information. The crew decides to aim for a region where the cosmic background becomes intense, because that will be their marker. The point where the universe ahead is so blue shifted that it becomes a wall of radiation. Not a physical wall, a wall of dangerous photons. The ship slows its acceleration further. It uses the last of its fuel carefully. It is now like a climber near a summit, moving slowly, not because the summit is far, but because the air is thin. The crew spends long hours at the observation consoles. They watch the last bright galaxies. They watch the last star-forming regions. They watch the last familiar colors, because they know that soon space will look like darkness. And then, in year 95, ship time, there is a moment. The forward cone is no longer filled with stars. It is filled with a diffuse glow. The cosmic background, blue shifted, has become visible. It looks like a faint, pale curtain, a whisper of the Big Bang. The crew is watching the oldest light in the universe with their own eyes. The documentary voice speaks softly. This is what the universe looked like before there were stars. Not exactly, but close. The crew's instruments measure it. They record spectra. They record intensity. They compare it to theory. And the theory matches. The ship has reached a place where the background of the universe is not background. It is front. It is present. This is the edge of what is useful. Beyond this, the radiation becomes too intense. The ship cannot push further. The crew knows it. They have reached the end, as much as a human lifetime can. The crew marks the moment, not with fireworks, with a quiet ceremony. They gather in the common area. They dim the lights. They play a recording of a human heartbeat, not as melodrama, as a reminder. This mission, no matter how cosmic, is carried by organs, by breath, by sleep, by fragile minds. The commander speaks. We asked, how far can a human go? The answer is not infinite. The answer is as far as a human life can hold. The commander looks at the forward feed. The pale curtain of the background glows. They add, this is our horizon. This is our documentary proof. Then the crew eats a meal together. Simple food, recycled water, a small dessert saved for years. They laugh. Not because it is funny, because laughter is survival. And later, alone, several crew members record private messages. To no one, to everyone. They speak into the archive camera. They say, if you are watching this, we are gone, but we were here. We saw the universe. We saw time. we stayed awake. Before the ship turns, the documentary spends time inside the last working years of deep speed, because this is where the mission becomes both science and character. The crew is older now, not fragile, but careful. Every movement has a history of aches. Every decision has a history of consequences. And yet, they still do their rounds. A maintenance engineer walks the habitat spine. They tap panels. They listen to vibrations. They check the hum of pumps. They check the smell of air. Because machines have smells. A faint, sweet smell can mean coolant. A sharp smell can mean ozone. A stale smell can mean the plants are stressed. The engineer narrates. On Earth, if something breaks, you call someone. Here, we are the someone. The documentary record shows the plant wall. The plants are not decorative. They are a mental health tool. They also stabilize humidity. They also provide a small emergency oxygen buffer. The botanist speaks. We cannot grow all our calories here. That would be too much mass. But we can grow green. Green is not food. Green is sanity. The crew eats rehydrated meals. They eat cultured protein. They eat carefully rationed treats. Once a month, there is something called Earth Night. They play recordings of rain. They show old videos of forests. They read old letters. They tell the same stories. Not because they are stuck, because repetition is how humans build home. And then, time dilation returns as a punch in the chest, because the crew keeps a record of what the outside universe would have done while they lived this routine. A scientist reads it out like a weather report. Ship time, 82 years. External time estimate, tens of thousands of years. Ship time, 84 years. External time estimate, more. The crew laughs. Not because it is funny, because the numbers are too large for feelings. So the crew ties time dilation to scenes. They say, when we left, constellations were familiar. Now, those stars are behind us, and their light is stretched. When we left, we could imagine the future as a sequel. Now, the future is a different genre. The documentary record uses a simple, grounded example. If you left Earth at age 20 and you lived to be 100, you have 80 years of ship life. But outside, your departure might be ancient history. There might be no memory of your name. There might be no one speaking your language. The crew discusses this. A technician says, we could be famous, or we could be forgotten. The commander replies, fame is not the goal. The goal is record, truth. The ship is a moving instrument. It measures the universe in a way Earth cannot. It measures how the cosmic background looks in a boosted frame. It measures how radiation environments change. It measures the structure of gas clouds far from the Milky Way. It measures the long arc of the cosmos through the lens of one human life. The documentary voice explains one more time dilation moment, one that a 20-year-old audience can picture. Imagine you are on a fast train. You look out the window, the landscape blurs. For you, it feels like minutes. For someone walking, it would take hours. Now scale that up. Perihelion is the train, the universe is the landscape, and time dilation is the blur. The crew also observes something subtle. As they push forward, more galaxies vanish, not because they are destroyed, because their light becomes too redshifted. It slides beyond the range of their senses. The universe is not disappearing. It is slipping out of visible bands. The crew widens their instruments. They use radio. They use infrared. They use everything. But there is still a trend. Less, dimmer, older. The documentary voice says it plainly. This is the end, as a human can see it. Not a wall, a fade. And then, in the last weeks of deep speed, the forward curtain grows brighter. The ancient background dominates. The crew stares. They are watching the universe's starting light, pushed into visibility by their motion. The crew holds a final scientific briefing. A scientist draws a simple timeline. Big Bang. First stars. Galaxies. Today. Far future. They point to the far future. They say, if you wait long enough, this is all that remains. A cooled background. A few dim remnants. Then even that. The crew is quiet. Not afraid. Just aware. Because they are not just traveling. They are witnessing the universe run down. And then, the commander calls for the final decision. Turn. Decelerate. Record the return. Because the story needs an ending. Even if the universe does not. In the archive, a mission scientist adds a final explanatory segment. They talk about the end of the universe, in the way a documentary talks about the end of a storm. Not with fear, with clarity. They say, when people say end of the universe, they often imagine a boundary in space, but the deeper end is an end in time. The universe cools, stars burn out, galaxies merge, black holes slowly evaporate. The remaining light redshifts into invisibility. The universe becomes a thinner and thinner whisper. The scientist pauses, then explains why the crew cannot simply keep accelerating forever. Because acceleration is not just fuel, it is also a fight against the background. At extreme speed, the cosmic background in front is blue shifted and can become high-energy radiation. You can imagine it like this. If the universe is a cold bath, and you run through it fast enough, the cold bath becomes hot in front. Not because it warmed, because you changed frames. So there is a practical limit, a speed where the forward headwind becomes dangerous, a speed where shielding and heat rejection become impossible. That practical limit is the crew's horizon, and beyond that horizon, the universe is not a place you reach, it is a place you infer. The scientist ends the segment with a soft line. The universe is not built for endings, it is built for running down. And then, the documentary returns to the crew. Chapter 6. The final turn and the quiet ending. The end of the universe in this story is not a cliff. It is a decision made by tired people in a clean metal corridor, far from every star they ever knew. The commander gathers the crew. We have reached our limit. We have recorded what we came to record. We have measured the background. We have watched the universe age. Now, we choose what to do with our remaining time. There are options. They could keep accelerating and die sooner, under radiation. They could turn around and attempt to return, not to Earth, but to whatever has become of the local group. They could stop accelerating, coast, and live out their lives in a moving dark. The crew votes. They choose the final turn, not for hope, for symmetry. They turn the ship. Turning is not like a car. It is a careful rotation. Thrusters, gyros. The ship's gravity shifts. For a while, down is sideways. Then, down returns. Now the ship is pointed back, not back to home, back to origin. The ship begins to decelerate. Deceleration feels like gravity too. It is the same trick, but now, velocity decreases. Time dilation changes. The crew watches their timeline. As they slow, outside, time slows relative to them. The gap narrows, but it will never close. They have skipped centuries. They have lived one lifetime, while the universe outside moved through many. The crew spends their final decades, recording, reflecting, teaching, writing letters that may never be read. They make a library of a journey. They leave messages. If anyone finds this, know that we were here. Know that we saw the universe change. Know that we stayed human. In the final year, ship time, the commander makes one last recording. Their voice is older. Their breath is slower. They speak to an imagined listener. We wanted a wall. We wanted a grand finale. But the universe does not do finales. It does fades. It expands. It cools. It runs down. And yet, inside that quiet, there is beauty. Because we were allowed to see it. Because physics, for all its cruelty, also gave us a way to trade time for distance, a way to cross what should not be crossable within one lifetime. The commander pauses, and then they say goodbye. In the last recorded minutes, the ship's systems continue their calm work. Air circulates, water cycles. A small fan turns, a light dims. The forward sky feed is mostly glow now, ancient photons, filtered and tamed, so human eyes can look without harm. A technician reads the last dashboard out loud, not because anyone needs it, but because saying numbers makes fear smaller. Acceleration near zero, fuel reserve minimal, shield temperature stable, radiation stable. The technician adds, if you ever build a ship like this, remember that the end is not a crash. The end is maintenance, until there is no one left to maintain. The commander lets the silence sit. In that silence, there is the feeling of distance, not as miles, but as eras. A lifetime on the ship, a vast age outside, a simple lesson, spoken without equations, that the universe is not only big, it is also slow. And if you want to cross it, you do not only need engines, you need patience. You need quiet courage too. You need shielding. You need the willingness to let everything familiar become history, move fast enough, and time becomes a landscape. Then the commander ends the record with the line the archive requires. This was a quiet archive story, where the story ends. Sleep begins.